Hi, welcome to my second video to assist students on the PEO Level 1 Electronics program. This is Nick presenting the 555 timer circuit constructed on breadboard. What's breadboard? Well, that's this construction board I've got here. How do you make a connection? Well, if you look closely, if I push a wire into a hole, you, I hope, can just about see the grips of the connection separating and allowing gripping on the wire, so that if I push a wire through a hole, I can make a connection. In this particular breadboard, there are runs of 5, so 5 connections there, 5 grips there, making 5 connections there. A gap in between those 5 and those 5, separate them, and then we have 2 separate runs of connections running the length of the board. So we have a red and a blue line. The red line guides us to connect a positive supply anywhere along there, and it'll all be connected together. If we choose to turn the board round or use the blue line at the top as well, we have a negative option at the top. Then at the bottom, a red and a blue, again all connected together, and them all connected together, so giving us a negative and a positive option at the bottom of the board. If you look carefully, you can see A, B, C, D, E, F, G, H, I, J, and 1, 2, 3, 4, and so on, all the way to 30. So 30 rows of connections separated down the middle. So each of the 30 is 5 connection pins connected together, but not to anything else. So by connecting in between these rows, we can build a circuit of our choosing. The circuit that I've chosen to build is the 555 timer, operating as a flashing timer, giving us in this particular circuit about a 1 second interval. So if I switch it on, we can see the light emitting diode flashing on and off. How do we achieve that? Well, there's 2 aspects to this particular circuit that you need to know: how the circuit in its entirety is built, and how to connect components into the circuit so that they're safe and don't self-destruct. So if I switch that off, and we'll have a little look at the components that I've used for this particular circuit. We've got 1, 2, 3 resistors, a light emitting diode, a 555 timer, and a capacitor. 2 resistors are in series with the capacitor. A third resistor is in series with the light emitting diode. This resistor is there to simply limit the current that can flow through the diode, so we don't destroy the diode. These 2 resistors and the capacitor are set up to set voltage levels which tell the timer when to switch on and off. Changing these values will change the rate at which the timer is going to operate. What values have we got? Well, we start with the resistors. You can connect the resistor in the circuit however you choose. These resistors are both the same. They're 4-band resistors, and if we look at the values on the bands, we have a brown, a black, and an orange. If we refer to our colour codes, a 1, a 0, and a 3. The 1 and the 0 make the number 10, and the orange is 3 noughts. So 10 and the 3 noughts, 10,000 ohms. The next resistor is exactly the same. The resistor which is connected in series with the light emitting diode is a yellow, a violet, and a brown. A 4, a 7, and a 1. 47 and 1 nought, 470 ohms of resistance. That's a nice resistance to have a reasonable current flowing through the LED without the LED destroying itself, getting too hot and conducting too much current. So in series with the LED we have a resistor which provides my flashing circuit to operate. The last part of the control that we're interested in is the capacitor, which charges and discharges to switch the 555 timer. This particular capacitor is an electrolytic capacitor. It's polarized. That means it has to be connected in the circuit the right way around. It can tolerate 63 volts. The value 47 microfarads. There is a band, silver or gold. This one's gold with a negative sign on it, which tells you which way around to connect the capacitor, so that the side with this strip goes down to the negative side of the circuit. Then to construct the rest of the circuit, we have links. So from the top of my board, we've linked to the positive supply my resistor, the start of the series resistor line. We have a connection from the supply down to pin 8. We have a link connecting pin 6 to pin 2. We have another link connecting pin 4 from the positive supply. We have a link coming in from between the resistors going to pin 7. We have another link from the capacitor resistor combination coming in to pin 2. And then pin 2 and pin 6 are connected together. The output from pin 3 goes through my LED and down to ground. The 555 timer itself, connected into the circuit, is connected to create the flashing light option. There are several more options, and if you want to find out a little bit more about those options, there's plenty more YouTube video to show the different ways we can connect up my 555 timer. So a little bit more about the circuit components that we've connected to make the circuit happen. Firstly, my 555 timer. The 555 timer has got a notch which identifies pin 1 and pin 8 on the chip. Here's my pin connections for the timer circuit. Pin 1 connected to ground. Pin 8 connected to the supply. Pin 4 also connected to the supply. Pin 7 in between the series resistors, sending a sample voltage to the timer. Pin 6 picking up a voltage between the resistor and the capacitor, sending a sample voltage into the timer. Pin 6 and pin 2 are tied together, and pin 5 I've left open. Pin 3 connecting to my light emitting diode and series resistor. Right, moving on. We now have a light emitting diode. The engineering drawing for the light emitting diode, an orthographic projection, which shows a long leg and a short leg. The long leg's the anode, the short leg's the cathode, positive, negative. There's also a flat on the cathode end, so as if you happen to cut the legs off when perhaps removing this component from the circuit and you want to know which way around it goes, well then you'll find a flat left on the cathode end to help you identify which way around to connect my LED. If you connect it the wrong way around, providing the series resistor is in place, you won't do any harm, you just won't have the light operating. It's a diode. It only works one way. The next engineering drawing, orthographic projection, is for my capacitor. There's a band on the capacitor which shows the negative side. There's the value of the capacitor, 63 volts, 47 microfarads. You might be able to see on the drawing a positive and a negative, showing you which leg is connected where. On the capacitor, the band showing you, or the stripe showing you the negative side of the capacitor, so the short leg to the negative side, the long leg to the positive side of the circuit. Finally, the 555 timer again, showing you the notch on the timer, identifying pin 1 and pin 8 and the remaining pins which we connected into the circuit, making particular care that we get pin 1 and pin 8, the ground and the positive supply, the right way round, and then the other pins connected to my resistors, capacitors and the light emitting diode which came out on pin 3. So there's a look at the 555 timer. The 555 timer circuit set up to flash the LED at 1 flash per second or very close to that speed. Any problems, any questions you'd like me to try and answer for you, send me an email and hopefully we can sort out the problems you might have trying to understand this circuit and its components. Speak to you soon.